Good morning, everybody. Welcome back. Today is Thursday, February 25th. And today's lesson is on a refresher of what we've been taught in grade 10. A lot of this stuff is going to go relatively quickly. A lot of you remember this, and it kind of has a good point of what we've been talking about in our first unit. And so, basically, what you see on the chalkboard, even though I want to start with solving quadratic by factoring, there's actually three forms of quadratics that a lot of you have been taught in grade 10. Standard form, factored form, and vertex form. If you forgot this, don't worry, right? Don't worry. But a lot of the questions you see right in front of you, although example one is not exactly the best one, they tend to be on the standard form. And a lot of you realize we have to factor to solve this now. What does that really mean? Usually, and again, I'm trying to show you visually, you have a parabola. It's not exactly this one, but usually when the parabola actually crosses the x-axis, in fact, if it crosses there at least twice, then we know it has roots, zeros, or x-intercepts. So this is actually what you're supposed to do when you're solving, when it actually equals to 0. Notice again, for example 1 from your handout, if you're following along, I just copied them out. In question 1a, when you want to solve this one, first of all, they're all in factored form. They're all in factored form, for example, example 1. In this example, this is not really a quadratic, but it's the idea there. And some of you are slowly kind of connecting how to do this. Basically, what is x when it's going to be equal to 0? So one more time, a lot of students take that factor. Notice you can't do anything with 5, because 5 is actually a number. There's no variable there. So x minus 10, and you make it equal to 0. And some of you are slowly connecting. We've kind of done this before. When? In our first unit with the restrictions, when it didn't equal to 0. In this case, we are actually finding, and that's why they're called zeros, or roots, or x-intercepts. A lot of you already know the answer for this. X equals to 10. Hopefully that got on the camera, that red chalk. If x was ever 10, this would be 0. Make sense? How about for this one? 2x times x plus 1. Again, this is already in factored form. You can't do anything with the 2. So this answer, or this solution, is x equals 0. That's for this one. Everyone see that? Because if x was ever 0, this equation would be 0. That's why I think a lot of you know what we're doing. How about this x plus 1 equals 0? Can someone from the class? This is now, notice example 1. It's going to fly. A lot of you know what you're doing. Abby, you want to try?
So x is negative 1.
Nicely done. Notice how she said it. She didn't say not equal to. These are all equations, and we're solving. Right? We're solving. Notice you can only do this when it does equal 0. If it equals something else, you say 5, negative 3, 2.7. You can't do what we're doing. Okay? Because the whole point of the definitions, we're solving when y is equal to 0. And that's why in grade 10 we call them zeros. I like calling them roots or x-intercepts. Notice for this one, let's see someone from the class. This is x plus 3 times x minus 4 is equal to 0. Preferably somebody new. Someone that hasn't said anything. No? Alright, Brandon, you want to try?
X is negative 3 and 4.
Now, I like writing it twice because that's just the way I am when I'm teaching it, but you can definitely write them together. Nice. Notice some of you realize, wait a second, I remember being taught this in grade 10. I'm getting two possible answers. Two possible answers. That's why in grade 9, this is a linear equation. The degree, this is degree of 1. There's only one answer. This is only one answer. But most of the time, there's at least, well, these quadratics, there's 2 of them. The last one here, for example, D. We have 2x minus 1 times 3x plus 2 equals 0. Any volunteer? Any volunteer? Abby, sure, go ahead.
So x is 1 over 2, and then x is negative 2 over 3.
Let's pause here. Thank you so much. Any volunteer, or so anybody that still doesn't know how we're doing this? Notice you had to do this when we were solving for our restrictions. And again, if you're not too sure, we'll just take the second one, 3x plus 2. Don't feel bad, ladies and gentlemen, if you actually had to write it as 3x plus 2 equals 0. That's okay. Subtract 2 to both sides. Divide both sides by 3. Any question about example 1? Really easy, right? And the reason why these ones are so easy is because they're in factored form. So a lot of you know from example 2, we're going to solve again, but this time they're not in factored form. That is why we have to factor. Now, some of you are realizing maybe from grade 10, if we can't factor, but they have two real roots. What do we do? Well, a lot of you realize in the future, we'll probably use a formula called the quadratic formula. Okay, what happens if it's actually in vertex form and it also has two roots? How can we do that? Some of you realize actually maybe you were taught by a good teacher named Mr. O how to unravel it, right? By using radicals. So I'll explain that in a moment. Everything kind of ties in. For this one, negative 4x plus 20 equals 0. Again, I don't really like this example, but I'm going to get it out of the way because some students always ask me. Notice factor first. So we're going to factor this. I think on the left-hand side we get negative 4 times x minus 5 is equal to 0. And once it's in factor form, that's the title of this lesson, solving by factor. The solution for this, there is only one, x equals 5. Before we continue, everyone okay? Am I going too fast? Any questions? Unfortunately, the sun's out, so maybe this recording is going to be washed out. So if you're watching from home, you might need to pause or enlarge the video. Now I'm jumping question C, if that's okay, because I like to do a bit more interesting ones. In fact, some of these are too easy for some reason. I don't know. In grade 10, you actually did a bit more challenging ones, but at least the idea is that. We have x squared plus 4x minus 32 equals 0. Can someone from the class help factor this for me? Factor? Any volunteer want to factor? Sophia, please.
It's bracket x minus 4 and then bracket x plus 8.
Is equal to 0. Before we continue, everyone okay? Anyone having difficulty? And don't feel bad if you're not factoring as fast. Well, you can see it once the answer is given. You can check by expanding, right? So if you don't want to finish off, what are the roots? Or sorry, what are they? 0?
X equals 4 and x equals negative 8.
Nicely done. Any questions? Am I going too fast? Everyone all right? Any questions at all? Question D. We're going to jump to question D. So the question is 2x squared minus x minus 21 equals 0. I'm probably going to do this one if that's okay. This one's a little bit harder, right? And the reason why, because this is not a type 1 factoring question, this is a type 2. So I think I'm going to do 2 and 1, and what makes it 21 is 7 and 3. That's it. 6 and 7, 8 and 1. So 2x minus 7 and x plus 3 equals 0. Let's have a little check. Did I factor that correctly? A little double check. Thank you. It's stressful. Everyone okay with that? And I'm pausing here for a second because for some weird reason in grade 10, seriously, grade 10, many students would just stop here. What are you talking about? I'm done. That's what we're doing, factor. But again, the idea is solving the unknown, right? So don't forget to keep on going. For some weird reason, I don't know why. When we solve things, solve for x, we want to know what it is. There are answers to this. That's why it's called solution, solve solutions. So different volunteer perhaps? Did someone try to help us? Preferably somebody new? Maybe, I don't know, Aiden or Daniel or Tina or Alessia or Kai, Matthew or Meg? Though Meg, you helped out earlier. Anybody? Or Amanda? Want to try it? You want to try to solve this one?
Sure.
If you get it wrong, who cares? It's only on YouTube. Sorry, name just doesn't go.
Negative 3 and 7 over 2.
Yeah! Way to go, look at that. Any questions still? Way to go. Any questions so far? Any questions? So I know I did A, C, and D. If you're looking at your handout, ladies and gentlemen, even those who are watching at home, I would actually cross out question F. I don't like question F. I mean, you can try it, but I don't like fractional coefficients for this one, when we're doing these kinds of questions. The only one I'm going to do next, and we'll erase this, is take a look at question example 2G. That one seems to be harder. Even 2H seems a little weird, but I think you can figure that out. But we're going to just do 2G. Because 2G is technically an unfair question. So I'll read it out loud to the audience and to the class. 2g is actually, example 2g is actually 3x cubed minus 12x equals 0. So the rule is to factor first. So here's what we're going to do. 3x is the GCF, and I think x squared minus 4 is equal to 0. Before we continue, any questions? We're not done, but any questions? So then, some of you already know I'm leading. Any volunteer want to help me out, Mr. Chen? The x squared minus 4? Mariana?
It's a perfect square. Whatever.
It's not a
Or
perfect
is it
square.
different?
It's a different square. It's nicely done. Way to go.
So
whatever.
it's like x minus 2x plus 2.
Nice. Any questions about that? Any questions so far? But notice we want to solve this question. So the ones in the factors are easy. That's x plus 2 for that one. That's x minus 2 for this one. And I think some of you are slowly figuring this out. This one's 0. So in this case, this is 3. Now you haven't done this before because this is technically not a quadratic. Any volunteer actually know what this is called? When the degree of the polynomial is 3? Anyone actually have an idea? What do you call it? Abby?
Cubic?
It is a cubic. For those that are really, really keen, we're eventually going to talk about it. I don't know what this looks like, I really don't. But it looks something like this. At negative 2, and at 2, and at 0, it looks something like this. Oops, I missed. Not exactly. So you don't have to worry about that. I'm just trying to show you what it visualizes. And that's what that means. It crosses at negative 2, crosses at 0, just like, but this one has 3 roots. Okay? Any questions from the class? No questions at all? Stop that.